Okay. Hello, everyone. First, we don't have a class on Friday because it's Senior Design Day, and IESP is actually occupied all day, especially afternoon. So we don't have a class on Friday. The only thing that we miss is a mini lab. So I'm going to give its grade to everyone. You don't have to do it for the makeup day. And we don't lose any of the, there isn't anything new that was supposed to be taught on Friday. Okay, everything is going to be covered today. That's the first one. For web work, you get one web work today, which is homework 20. One you were supposed to get on Friday, but I already opened it. Okay, so 21 is open, but you get the same amount of time plus 2 days for 21. So it's not going to be due sooner because I opened it sooner. Okay, that's the next one. Yes.
Were there like 24 web works?
I'm not sure, 26 or something. But usually the last one or two, I won't open them. Okay, if I feel that they're gonna be due way past the third exam, and there's no point. And what else I wanted to talk about? I think that's it. Yeah. Okay, let's do a quick review of the previous lecture topics. So we introduced the concept of impedance, which is like a high class or fancy term for resistor in phasor domain, okay? So I want you to remember, what is the impedance of a resistor? Itself, R. What is the impedance of an inductor? J omega L. What is the impedance of a capacitor? 1 over J omega C or negative J over omega C. They are exactly the same. So these are the impedances. And remember that R is a positive real value, J omega L is a positive imaginary value, and negative J over omega C is a negative imaginary value. Okay? That is the first thing. Now, the second is that I want you to be able to change any time domain function, cosine function, in less than 4 seconds to its equivalent phasor. So the only two things that you should focus on are amplitude and phase. See, that will give you the phasor. Of course, if it is in negative cosine, you have to first change it into positive cosine. If it is in sine form, you have to change it in cosine, okay? Phasor is defined based on cosine. If you remember, for an electrical circuit, we were able to say, we were able to talk about input resistance. Now, that was for DC circuits or time domain circuits, okay? Now, for sinusoidal excitation in phasor domain, we have equivalent impedance or input impedance. So everything that we talked about for time domain and DC circuits can be upgraded to phasor domain. One more thing. We have two region or two domain of analysis. The first one is called time domain, and the second one is called phasor domain. Everything is changed to phasor. Now, the phasor domain is also called frequency domain. Can you tell me why? Do you know why we can call the phasor domain the frequency domain? Or let me ask you a simpler question. In phasor domain, what variables or what values are frequency dependent that we can call it frequency domain? Is it frequency dependent angle? No. The angle is only depends on phase. It doesn't depend on frequency. What depends on frequency? Just look at the table. The values of the components. Do you see that? What's the value of an inductor in a phasor domain? J omega L. So it means that if I change the frequency, the value of the impedance would change, right? That's why we call it frequency domain, okay? That's just a naming convention. And finally, I want you to remember that impedance has two parts, like any other complex numbers. It has a real value, which is called resistance, the units of which is, you all know, ohm, and reactance, which is the imaginary part, and the units is, again, ohm. What's the units of impedance? Again, ohm, okay? Just to show you that this could be as important as appearing as a question, look here, question 4, last year fall. The imaginary portion of impedance is more commonly known as reactance and is measured in ohms. Okay? So that is the answer. Very good. Now, let's do an example. An RLC network. What does it mean, RLC? It means it is made of resistors, capacitors, and inductors, operating at a frequency of 60 hertz. So your F is 60 hertz. Immediately after you get the value of F, what should you calculate? Omega, 2 pi F, which is 120 pi. What's the units of omega? Radian per second or 1/2. Yeah. Has an input impedance of Z in equals to 4 plus J6 ohms. Comment on the internal circuit of the network. Okay? So, first of all, this is your Z in, or input impedance. 4 plus J6 ohms. Now, how can I comment on this? Okay. Can you tell me what is R in? Someone said it. 4 ohms. Remember, any impedance can be broken into real and imaginary parts. So R in is 4. What is X in? 6 ohms. Okay. Let me copy the circuit. So what's the meaning of input impedance or input resistance? It means that if you, let me talk about resistance, input resistance. It means that if you connect the two ends of a multimeter on ohms mode, on resistor measurement mode, to the terminals, it will tell you what resistor it is sensing. For example, if it was sensing 10 ohms, do you agree that I could replace the whole network with just 10 ohm resistor? That's the meaning of equivalence, right? But right now it's impedance. So do you agree that whatever the multimeter or your upgraded multimeter is sensing from across the terminals of the input is 4 ohm real and J6 ohm as the imaginary part, okay, as the imaginary. So can I, it's like that. Do you agree with that? Why did I draw them in series? Because they are being added. When are you allowed to add two impedances? If they are in series, okay? So do you agree so far with whatever I've written? Now, when a block, a component is 4 ohm, what does it mean? It's just a resistor. So I'm going to remove this block and put it as a resistor. How about J6 ohm? Can it be a capacitor? What's the difference between capacitor and inductor in terms of impedance? Both of them are imaginary, but capacitor is a negative value. Only inductor is positive. So what is the other element? Inductor. Very important. I want you to remember this. Inductors will give you a positive imaginary impedance. Okay. Now, what is the value of R? 4 ohm, very easy. What is the value of L? So what we know is that J omega L is equal to J6. Do you agree with that? That's the impedance of the inductor. So how can I find L? Omega is 120 pi. I don't have the value. Can someone calculate it and give it to me? Point 0.01. Any problem with understanding this? No? If you have a problem, this is the time and place to ask. Okay, now, are we sure that what's inside the block is a resistor and an inductor in series? Could be thousands of elements. The equivalent behavior is like that. For example, could it be don't need to make it big. Could it be like that? Yeah. Because they are in series, how do you combine them? Add them. What is J8 minus J2? It's going to give you the same, okay? So we don't know what exactly is inside the network, but the equivalent or the input impedance is behaving like it's a resistor plus an inductor. Did that make sense to everyone? Okay? IS is given to you for this circuit, and it is asking you to find Vs. Now, this is my question. Have you seen something similar to this circuit before from the previous lecture? How did we solve it? I don't mean in terms of circuit techniques. How did we handle?
But that's not in phasor.
No, that was before introducing phasor. We did trig identities. Do you remember that? Almost took one full page of trig identities, manipulations, and everything. Okay? This is very similar to what we did. I'm not sure if it is exactly the same, but this is how we did it. Let me actually pull it up. It was lecture 22, right? Oh, why is it white? Oh. Here it is. Oh, it's exactly the same. Okay? See? We wrote a KVL in time domain, and then we did all of this, more than one page, okay, to find the final answer. Okay. Now let's do it using phasor domain. What is the first step if you want to use phasor domain? Transform everything from time domain to phasor domain. When I say everything, what do I mean? It means all the voltages and currents should be written in phasor form, and all the resistors, capacitors, and inductors should be replaced by their equivalent impedance. Okay? So that is how I'm going to write it. What should I write instead of IST? IS bar as the phasor equal to 2 angle 12 amps. What should I write instead of the resistor? 6 ohms. That's it. Resistor is always itself. What should I write instead of the inductor? J omega L. J. What is your omega in this problem? Do you all see that it's 5? Where do you get it from? The coefficient of t inside the cosine. That is omega. Five. And the value of L is 2. So it's J10 ohms. Right? And what am I looking for? I'm looking for VST, but since I've moved to phasor domain, I'm going to write it as a phasor, the VS phasor. Okay, now, this is the circuit that you're supposed to solve, and I claim that it's going to be much easier. What do you suggest? To find VS. Current time, all the resistors combined. But one might say, but it's not all the resistors, it's just one resistor and one inductor. Does it matter in phasor domain? No, they are all impedance. So you can combine them. Right? So I'm going to write the equation, and then you see that you like it or no. Any problem with that? Current multiplied by the total impedance in the circuit. Why did I add them? Because they are in series. Were you able to do this if it wasn't in the phasor form? No. because the equation governing the behavior of inductor is not Ohm's law, but in phasor form it is. So it's equal to, what is IS? 212 degrees amps multiplied by 6 plus J10 ohms. Give it to your calculator now, everyone, okay? I want everyone to do it. And give me the answer. Do you have it, Aaron? Yes, tell me.
I got 7.58.
Yes, 7.58 plus,
Plus 22.1 basically.
don't forget the J. The second number that you're reading is the imaginary part. 22.06, right?
Yes.
Okay, yeah. That is the VS that you're at. Yes?
Does the position of the J matter? Can we put
No. You can either put it after the number or before. Yeah. I'm used to putting it before, but many of the engineering texts, they put it after. Okay? Okay. Am I done with the problem? Who is electrical engineering student here? Who else? Braylon? Yeah, I know person. Okay. Imagine that you're hired by an electrical engineering company and they ask you to do this for some specific problem. And you call your boss, okay, sir, I found the answer. And it is 7.58 plus J22.06. Either you get fired or you get slapped and then fired, okay? Because he probably doesn't understand what the hell that means. Why? Because it's not a real answer. The real answer would be in time domain. That's what is sensible for people. That's what can be measured. So how can I go from this to time domain? That is where my second question starts. What representation would we prefer as the answer to our phasor problem? Do we prefer the rectangular form or polar form? Just to understand that, give me the polar representation as well. You should be able to change this very fast to polar. Tell me what it is. Do you have it, Cage? Who has it? 23.32 angle. Angle 71. And let me write the units as well. It's in volts. Now, this was my question. If I want to change my final phasor form answer into time domain, which one is easier? The second one actually can be done in 2 seconds, right? Look at it. How can you write it in time domain form? So 23.32 is the value of the amplitude, right? You ignored cosine so far, bring it back. You ignore omega t so far, bring it back. What was omega t? 5t. Plus, what was supposed to be here? The phase. So just put 71 degrees. That is V. VST. Make sense? Which one I prefer? Now I want you to remember this. Right now, for most of our problem, we prefer the phasor form, okay? But in the topics that I start next week, there are some problems that I prefer the rectangular answer, okay? So you must be able to alternate between them as fast as you can. Any problem, just be honest and tell me if this is an easier way of doing this circuit compared to the sinusoidal manipulation with trig identities. And remember, this is just one loop. So it was like multiple loops that would create something that you probably never heard of. Have you ever heard of system of differential equation? So the worst of the two words, right? First of all, is a system of equations. Second of all, the equations are differential. You would get a system of differential equation, which is a very hard thing to solve. But here you will get a system of equation, okay? Everything that is related to differential equation is just removed from your analysis. Okay. Let's go for the next problem. Vx and Iy should be found. Is and Vs are given. Okay. So remember the title of this lecture and the previous lecture. It's a steady state, right? We assume that all the transient responses are gone. So we are in the steady state. Now, this is my question. Since we are in a steady state, can I just replace the inductor with a short circuit and the capacitor with an open circuit?
Yes.
Because it's steady, so you're not fluctuating.
What was wrong with his statement? He said they are steady because nothing is fluctuating.
Steady state doesn't mean it's still time.
Look at your sources. Are they DC values? No. They are cosine function. They change forever. So nothing is DC in this circuit. There's no way you can replace them with short circuit or open circuit. Why am I saying this? Because I don't want you to remember anything about the second exam on the third exam. Okay? Forget everything that you did on the second exam. Replacing the inductors with short circuit, replacing the capacitor with open circuit. This is sinusoidal excitation. Forget it. Okay? So what is the first step? Transform everything into phasor domain. I'm going to start with Ethan. What is, start from the left. What is the phasor domain expression?
Is phasor equals 2 angle -45 degrees.
Next, Aaron, capacitor value.
Negative J over
Omega C, right? And give me the value that it gives. What is omega? 1 radian per second. Do you agree with that? The coefficient of t is your omega. So negative j over 0.5. So it's negative 2j ohms. Set the inductor. Don't say W. J omega L. is equal to, omega is 1, L is 4, so J 4 ohms. I'm gonna write this one myself because it's easy. 5 ohm. I'm gonna write the label here at Vx bar, which is your phasor. And what is Vs, Cage? 14 angle 65 degrees volts. Okay? I changed everything into phasor form. Now, what's next? Can I combine the two impedances in the middle? Okay, whoever says no, I would ask then what's the point of changing everything to phasor domain, right? That's one of the biggest advantage of phasor domain. You can combine everything. Okay, so let's combine them together. What do you get? So let me put it here. So I'm going to remove whatever is here and then put a block here, and the value is J2 ohms. Do I care what kind of a block is that? No, because, well, it's not a single block. It's a combination of a capacitor and inductor. The only thing that matters is that its impedance is J2 ohms. Okay, what do I need to find? Vx and Iy. Where is Iy? I lost it. Here. Okay, which one do you want to go first? I think it doesn't matter. We can actually find both of them. So what do you suggest we do to the circuit now? Where? You want to go for KCL, he said. So I'm supposing that you're going to get this one grounded. Yes. Then you're going to call this one something. What, let's call it VY or V1? V1. And let's, is this a known 2 or no? Is it? No. 14 with angle 65 degrees volts. Any problem so far? Okay, write a KCL at V1. William. Sorry, again? I'm writing KCL at V1. Can you come again? Whenever you're confused, in your, just imagine everything replaced by very simple resistors, and then do it in your brain and then go back to real life. So to the left-hand side, there is just one current source, right? Whatever value it has, is it entering the node or exiting the node? So do you consider it negative or positive? Negative. So what should I write?
-2 angle -45 degrees.
Next.
Plus I1.
We don't prefer using IY, if you remember. What do we do? What did we do in writing nodal analysis or KCLs? Do you remember the red box? Jonathan?
V1 over J2.
V1 minus 0 over J2. Next. Canon.
V1 minus 14 equals 65 over 5.
Equal to 0. Okay, what should I do next? One equation, one unknown, all right? So this is what I do. V1, 1 over J2 plus 1 over 5. I factor out V1, find the coefficients, and take everything that doesn't have V1 to the right-hand side. I'm not sure if your calculator can do it in the initial form, probably not. So you have to do some do you agree with what I have written? Simple algebra, right? Just treat the complex number like normal numbers. And from here, now it's your turn to give it to your calculator and give me V1. Remember, the right-hand side divided by the parentheses. Ross, can you give me the answer? Are you doing it?
Yeah.
Okay. Do you have it? Say it. It's fine. Is it in rectangular form?
Yes.
Okay, can you change it to polar or no? If not, Samuel. Do you have it or no?
I have it in rectangular. I can convert it.
Yes. You know why I'm suggesting you give it to me in polar, right? Exactly. No. What else? I want you to get to the right number. What do you have, Brett?
6.094, angle 41.03,
No.
27.5.
No.
I got divide by 0.
Yeah.
5.255.
Yeah, that's the one I have. 5.255. Angle 91.59. That's why I ask you to do it in class. Whatever problem you have, I want it to be solved before the exam, okay? So that is V1. What do you need for this specific problem? You need Vx. What is Vx? V1 minus 1465. Guys, I have the answers, okay? I'm not lazy. But you do it and you give me the answer right here, okay? And I won't accept pass from now on. So either be absent or give me my answer. Consider that a threat. What are you scared of? Just if you didn't do it, just throw a random number at me. I said next. Okay, what is Vx?
V1 minus five.
Yes. Who's next? James. No, that James. Have you done it or you're still doing it? Oh, okay. I forgot. Xavier, I'm guessing you're not. You didn't bring your calculator, did you? Oh, yeah. I don't want to get into trouble for that. Braylon. I like his honesty, though. Okay, who has the answer? Vx.
9.594 and negative 129.1.
Yes. 9.59 with the angle negative 129. So, is that acceptable as the final answer? No, unless the question is specifically asking for the phasor. But what is Vx in time domain? Very fast. Next person, the other James. Focus on these two guys, this and this. So the first one is the amplitude, the second one is the phase. So what should I write? 9.59 cosine t 129 degrees volts. That is it. Okay? Now, I need one more thing. What is that? IY. How do you find IY? Next, Luini. Don't say the P word. Okay, let me make it easy for you. I have V1 equals to 5 volts, and this is 5 ohm. What is this current? V over? Okay. So now try to think outside the box. The same scenario. V1 minus 0 over 2J or J2. Exactly the same. The only difference is that the numbers are complex. So remember, IY is equal to V1 minus 0 divided by J2. Give me the answer. Look. Two point 63, okay. Angle. Degrees. Now, Hannah, can you please change it to time domain for me? Two point 63.
2.63 cosine t would be that angle minus 180.
No, the angle that you have, 1.59.
Yeah.
1.59 degrees amps. That is your final answer. Okay? Any problem? Now, one bonus question. Okay? Without using your calculator, the one that Luke did, could someone tell me the angle of the answer to this highlighted part without using a calculator? The 1.59 without using a calculator. You don't have to know it at all. But it will mean that you are very comfortable with the concept if you can answer this question.
Zero?
Sorry?
Is it zero?
No, it's not zero, it's 1.59. I'm asking, how can you get to 1.59 without a calculator? No bonus? Huh?
Inverse tangents is the.
No, don't go there. Don't go there. Do you remember? Just one help. Yes. No. How can you put it in rectangular without a calculator?
Tangent at zero.
But by without a calculator, I don't mean took you like 1 hour to write it on a paper.
Are you talking about tangent at zero is zero?
No.
Like how the graph works?
No.
Is it just 91.999? Oh,
Why?
because J is 90.
Perfect. What's the angle of the numerator? It's V1, which is 91.59. What is the angle of the denominator? Where is it located? J2. The angle is 90, so 91.59 minus 90 is 1.59. Okay? Do you see that? You don't have to do it in any shape or form, but it will help a lot if you understand where is it coming from. Okay? Send me an email. Okay? Look, send me an email and remind me of this. I will give you a bonus point to your final grade. Yeah. You only listen to these part of lectures. What was the last time that he just woke up? Okay. Let's do some sample problems from exam 3 last year, fall 2024. Okay? For the phase diagram shown below, which of the following statements are true? First of all, one very important question that you have to answer. Hold on. Okay. In which direction these guys can move, these phasor diagrams? Counterclockwise, okay? Not clockwise, okay? So, look at choice A. YT lags XT, okay? Let's find where YT is. So this is X. Bold it a little bit. And Y is green. So, when it says YT lags XT, what does it mean? Just to help you, remember how I made an analogy with this running around the classroom previous lecture. So if it says yt lags xt, it means that who's chasing who? Y is chasing x, right? Is it obvious for everyone? Because it's behind, it's lagging. So how can y chase x? Counterclockwise. So what is the angle that you have to measure to find by how much they are leading or lagging? From y in the counterclockwise direction go to x. This is the angle. By this angle, I'm going to give you two statements. Let me know if you agree with them. By this black angle, y is lagging x. Do you agree with that? By this black angle, x is leading y. Do you agree with that? Okay, let's look at choice A. Yt lags x by an angle between 0 and 180. That's correct, right? That is correct. Let's go to choice B. Where is z? Z is the red one. Okay. Z lags y. What does it mean? It means that z is chasing y, okay? In the counterclockwise direction. Z, y. How should I draw the angle if z is following y? Start at z and get to y, right? This is the angle. Now look at choice B. Z lags y by an angle between 0 and 180. Is it correct? No. C. X lags z. It means that I should start from x, go in the counterclockwise direction, and reach z. Start from x, reach z. X lags z by an angle between 0 and 180. Is it correct? No, because it's more than 180. D. X leads z. Where should I start? Start from z and get to x in the counterclockwise direction. Where is z? Here. Is it between 0 and 180? Yes. Next one, z leads y, means that y is the one chasing, right? Z is escaping, y is chasing. Y is chasing z, so I should move from y to z. Between 0 and 180, is it correct? And finally, y leads x, so I should start from x and go to y. Is it between 0 and 180? No. So the answer H is correct. Okay? Is there anyone having a problem with understanding this chasing, this leading, lagging? Remember that you only can move counterclockwise when you're talking about angles. This one. This is a question. We actually had two questions exactly like that. I'm not going to write anything. Give it to your calculator and tell me what the answer is. Remember, you're given A and B and C. You need to find A times B plus C minus B conjugate. That's a math question. Just one question before you answer. Which form would you prefer as your calculator answer? Polar or rectangular? Rectangular? What is the question asking? Magnitude. Can rectangular give you magnitude? No. It's polar. Do you have it? Okay. Was everyone able to get F as the magnitude in polar form? Is your calculator able to do conjugate? Okay. If you don't get it, repeat it. See what's wrong. The parenthesis is missing. Yeah.
Initially put in the calculator. Do we just,
Sorry, I didn't understand your question.
I can't hear what I do.
Probably missing some parentheses. It's possible.
Would you mind that?
Sorry?
Would you mind?
I don't understand.
Would you mind like working out?
How can I work it out? It's a calculator, right?
Show us what we can change.
If you mean this, that is B, what is C? Okay, that is how it.
The conjugate of A is -6 plus 3J.
Yes. So, what you need to do is this. First, do inside the brackets. I'm guessing that shouldn't be difficult. Whatever the answer is, to inside the brackets. Multiplied by 1 plus J8. And then I'm going to write this for you. This is plus 6 minus J3.
Okay, so you get that and then you take the magnitude. But I get like a 3-digit number.
You get a 3-digit number? What is it?
1352.
Is that a 3-digit? So you did inside the bracket
Yeah.
and then multiplied by 1 plus J8. Inside the parentheses. and then plus 6 minus J3, and then you change it to polar. So how do you get the magnitude then? Oh, and the magnitude that is given to you is what? Is it the correct answer? Okay, so bring it to me after I'm done with the lecture. What did I do to the question 16? Jesus. I removed it? Okay. For the sinusoidal signals x and y, which of the following statements are true? What should I do? Write them in phasor form. So that is the phasor x is equal to what? 6 angle 0. So first change this to cosine. Plus 5 angle negative 90 degrees. What is the phasor y? Okay, what's the next step? Find x as one phasor, not the sum of two phasors. What is it? Give it to your calculator. 6, 0, and 5, negative 90. 7.81. Negative 30. Okay. What's the next step? Oh no. That's a different type of question. What's the next step? Either in your mind or on paper, you should draw something. What is that called? Phasor diagram. Okay? So let's start with x. Do I care about the magnitude or no? No, because I'm talking about lead and lag. 39. That is your x. Where is y? 51. What is the angle difference between them? Is 51 minus 39.81, which is what? Right? Which one is leading? X is leading by 11.19. Or you can say y is lagging by 11.19. Now, you can right now answer the question. Which one is correct? B. See, x leads y by 11.19. But I want you to be able to tell me or finish this. Y is leading x by 360 minus 11.19. So remember, if I want to see by how much y is leading, then I should move from x all the way around until I reach y, right? Did that make sense to everyone? Any problem? Okay. So it's asking for equivalent impedance. What should I do? Impedance of every element. So because I want you to be able to do it, let's see who's next. Let's start with camera. Yeah. What is the, not the resistor, what is the impedance of the capacitor 62 microfarad? Okay, give me the final value. Remember, negative j over omega c, but I'm interested in the value. Is that the same that you have? I need two same answers. Negative 1?
I got negative 358. Same as the first I don't know. Did you multiply by 2 pi?
I don't have the answer. Oh, let me do this. Okay. Okay, if you're... So, oh yeah, it's good that you didn't say the correct one. So can I use that in my calculation? What is it? This is F. What do you need for your calculation? Omega. So what is omega? 2 pi times this guy, which is 90 pi radian per second. Okay, so negative j over 90 pi times 62 micro. I don't care what the value is right now. I just want to move to the next one, but thank you. This one is 15 ohms. The other capacitor is going to be negative j over 90 pi, 35 micro, and the other, oh, I forgot this guy. This is j 90 pi, 45 milli ohms. Which is actually j omega L, if you remember. And the other one is 42 ohms. Now, because I don't want to spend time on doing this, because the rest is just you and your calculator, I'm going to call these Z1, Z2, Z3, Z4, and Z5, and you tell me what is the equivalent impedance from across terminals A and B. So you start with Z1 plus Z2. Why? Because they are in series. Then in parallel with Z3. Then the whole thing plus Z4 plus Z5. And that would be your Z in, or ZAB, or Z equivalent. Okay? In the circuit shown below, okay, in the circuit shown below, Vs is given to you, and it's asking for Vx. So what is the first step? Change everything into phasor form. So this is going to be the phasor of Vx. The resistor is 8 ohms. This resistor is 3 ohm. This current is the phasor Iy. The capacitor is negative J over, what is omega in this problem? 10 radian per second. So negative J over 10 times 88 milli. Find the value for me, please. This one is J omega 250 milli, which is 2.15 ohms. Give me the value of the capacitor if you can. Let me make sure I have the value or no. This is what I have, negative J 1.136. Negative J 1.136 ohms. Okay? Now I replaced everything with its phasor form. What now? Do whatever you know about circuit analysis and find Vx and Iy. For example, what do you suggest? Who's next? Chaz. What do you suggest we do for this circuit to find Vx and Iy? Or for this problem, it's actually asking for Vx.
I would probably do KVL. Since we're looking for, yeah, we're looking for.
You mean mesh analysis by KVL? Because you have two loops. Which loop you want to write mesh? Is mesh good for this?
Not really,
Why not?
because it gives current.
But it gives you current, right? You're exactly right. But the thing is about the circuits of the third exam or even the second exam. For every circuit, you don't get just one question. So look at the next question. It's asking for Iy. So if you do it, you're actually killing two birds with one stone, right? So that's not a bad idea to do mesh analysis and find I1 and I2. But there's a serious problem. It's going to give you a lot of headache for the third exam. If you write two equations for the mesh analysis, you will end up having a system of two equations and two unknowns. Do you agree with that? Your calculator cannot do system of equation with complex numbers. No system of equation with complex numbers. So either one equation, one unknown, and you just do it yourself with the help of the calculator, or you can use MathCAD, but you don't have access to MathCAD. So what's the strategy here? Avoid getting more than one unknown in your equations. Otherwise, you just blocked. Okay? So what else do you suggest for this?
Let's find equivalent impedance
Of what?
of all that.
It will give you the current.
So,
How about, like, mesh didn't work, right? How about nodal? Is nodal working? Let's see.
it's worse.
Okay, so this is ground. Remember, there's nothing wrong with mesh. There's something wrong with your calculator, okay? So mesh itself is not a problem. So let's see. Is this unknown or no? No. We have the value actually is, what is it? 15, 30 degrees, right? Won't. So the red node is not an unknown. It's 15, 30 degrees volts. This guy is unknown. What should I call it? V1, right? We don't have V1. Let's call it just V1. Do we have another node or no? Yes, we have something. We have another node. So if I go for that, then I will get two equations, two unknowns, and I don't like it. What do you suggest? Sorry? You can't because you need two equations.
Do the algebra. So the voltage drop across the inductor and the resistor would be the same as across the capacitor, right? So you could do something like that to simplify.
Still waiting. Be as creative as you want before the exam. That's not gonna help, I don't think. Sometimes it helps, but let's see. So if I combine the 8 and J 2.5 ohm, what's gonna happen? I've destroyed Vx, right? But the bright side is that I will only have one unknown, right? If I combine them. Then I will find that unknown, which is V1, and then I move to the next one, which is find Vx based on V1. Now this is my question. If I have V1, how do you find Vx? Voltage division, okay? So this is the part that's trickier compared to the first two examples. Sometimes you have to break your problem into two problems to avoid getting into system of equations, okay? If I combine these two, I can do just one nodal analysis for this one and get on with it. But since I cannot do system of two equations and two unknowns, I better do it, find V1 first and then do a voltage division, okay? Is there anything else, any other way that you can think of? I don't see. What Cameron was suggesting to find the equivalent impedance of the whole circuit, okay? So if you find the equivalent impedance of the whole circuit, then you can find the whole current, but after that you have to do current division to find the current and then multiply it by the impedance to give you the Vx. Yeah, that is, I think, equally good. I mean, there's no
And then
disadvantage.
would you also get, you get IY from that, right? Correct? The current division, the same.
No, it's not the same. It's the other branch.
But you would get the division between the two.
Yeah, so you have to do current division. It will give you the current that's passing through the 8 ohm and the inductor, and then the other current is very easy to find. Yeah. So let me see if there's any other way of doing it. Oh. I think what Red was suggesting, source transformation, that could actually be a good idea. Let's see, let's do that one instead of nodal. Let's do source transformation and see where I land. I believe that was actually a very smart way of doing it. So I'm going to remove this guy in the middle and replace it with a current source in parallel with a resistor. What is the value of the resistor? 3 ohm. What is the current source value? 5 angle 30 degree amps. How did I get that? I divided the voltage source by 3. So if that is giving you problem, let me write it in the form 15 with the angle 30 degrees divided by 3. Okay? Now, yes, that is way better. How do you find IY? Current division. How do you find Vx? Again, current division multiplied by whatever impedance that you have. For example, let's call this guy something relevant. Ix. Can someone tell me what is Ix? Five angle 30 multiplied by what? It's very important for me that you are able to tell me what is the current division here, because that's completely based on your knowledge of the first 2 parts of this course, not the third part. How do you do a current division? If you have a problem with that, just think of this. R1, R2, R3. IS. How do you do current division if you want to find I1? IS multiplied by 1 over R1, 1 over R1 plus 1 over R2 plus 1 over R3, right? Do the same thing here. You have 3 branches in parallel. So what is Ix? 1 over what? Compare them and tell me. 8 plus j 2.15 divided by 1 over 8 plus j 2.15 plus 1 over 3 plus 1 over negative j 1.136. That is Ix. So this is current division. Source transformation.
Oh yeah, for when you have like 8 plus 2.15J, does impedance, what combine those two as one, or are they still distinct as real in the imaginary? Because technically the J is imaginary.
Yes.
So are you not allowed to combine them?
We already combined them.
Well, so
I wrote it as 8 plus j 2.15. How else would you be able to combine them?
you can't get 10.
Absolutely not. One doesn't have j. Yeah, you cannot combine the real and imaginary. But remember that the whole thing is just one complex, can be thought of as one complex number. One complex number that has real and imaginary parts. Right? Do you have anything for this? 0.628 angle. Amps. Someone else confirming this? Okay, now what is Vx? J 2.15 ohms multiplied by Ix equal to the angle should be 42.98. Is it?
42.8.
89, sorry. Yeah. Or 88 actually.
8, 7, yeah, 8,
88. Okay, what is the magnitude?
1.35.
Sorry?
1.351.
1.351. What is, and the angle was 42.88 degrees volts. Let's see if that is here, which fortunately is. Okay. How do you find Iy for the next question?
Just do,
You can do another current division, find the current Iy, right? So I'm gonna write it like that. So if this is Iy, the only thing that should change is that in the denominator, you should put this guy. Do you have the answer? Anyone?
4.58. Angle 57.922.
Okay. Choice G, right? Okay. Any problem? Let's go for this one. It's given you, well, this is way easier. Why? The circuit is already in phasor form. So the values, you don't have to transform anything. So everything is here ready, 15 degrees, but I actually don't need this guy. I'm going to do something. I need to find Vx, right? Now this is my question. If I first of all, can I combine the capacitor with its parallel resistor or no? Yes. Why? Because they are both impedances in this domain. So 15 in parallel with negative J 29 ohms. Give me the value of that. How do you make them parallel? Multiply divided by the sum. That's give you the value. What's the value? 9.89. The rest. It's not possible. The parallel of a capacitor and a resistor cannot be a resistor. So it needs to be either in rectangular form or polar form. So which one is it? Give me the value. I'm waiting. Yes.
13.1 volts,
Whatever, it doesn't matter.
13.32, angle negative 27.35.
Ohms. That is what? This guy. And where is Vx? Vx is here. Now, give me the parallel of the inductor and the resistor. J16 ohms in parallel with 5 ohms. What is the value of that? 4.77 angle 17.35. Someone confirm it? Someone else? Yeah, okay, good. Now, first of all, this question is asking for Vx. Does it hurt that I combined the 15 and negative J29? Am I destroying Vx or no? No, because they are in parallel. It doesn't do anything. So I still am able to find Vx. So how can I find Vx now? Voltage division. 20 angle 15 volts multiplied by what? 13.32 angle negative 27.35 degrees divided by 13.32 negative 27.35 degrees plus 4.77 angle 17.35 degrees. One more thing, one more detail that you have to pay attention here. What is that? With the way that I've written it, something missing from my equation? Do you see that why? Look at the polarity of Vx, the way it's defined. It's opposite. So that's why you need a negative sign for your voltage division. So that will give you Vx. I don't know, I don't have it, but I'm guessing it should give you the red one. Tell me if you're getting this. Are you? Okay. And that is your Vx. How do you find Iy? So you can either do voltage division, but I'm guessing subtracting is easier than voltage division. So let's call this thing, let's copy that for the next problem. Let's copy that and let's call this Vy. So do you agree that Vy is equal to 20 with the angle 15 degrees plus Vx? I just wrote a KVL around the loop. You can find it easily. Okay? So you can find Vy from here. And then what is Iy? Vy divided by 5. And you're done. Any problem? Okay. Now I'm going to talk about your web work problems for a little bit. So one very important result from today's discussion is to know what should you avoid as much as you can? More than one. Even 2 is problem, right? Okay, for example, this is the homework that is open today for today's lecture. How do you find I1? Combine everything, all the impedances, you get one whole impedance, right? And then divide Vs by that impedance, it will give you I1. What is the dumb way of doing this problem? On exam? Mesh analysis. Right? Okay. So after you find I1, how do you find I2 and I3? Current division. This guy. Dumb way? No. Mesh. How about nodal? The bottom node can be ground. The top node can be your unknown. How about those middle nodes between the elements and the voltage sources? They are all known, right? Because they are connected to a positive part of a voltage source. Okay? So one equation, one unknown. Is there any problem? No. So you can find the voltage up top. After you find that voltage, can you find I1? Yes. Vs minus that Vx that you just found divided by J5. How about I2? Vx minus 0 degree divided by negative J4. Right? Next problem. The only thing in this problem is that instead of writing it in cosine form, it's written in this form. But you already know what that means, right? You're familiar with this. I actually gave you this, right? So can you tell me the equivalent cosine form of this response? 125 cosine 40t plus 111. Nothing special, okay? Now, which one? IC is given to you. So what do you suggest we do in order to find Vs?
I would do this first one, just combine and then do current division, right?
The opposite of current division, actually. Do you understand what I'm saying? So the equation of the current division is the same, but instead of I'm not going to solve it for you, okay? I don't have a problem with you doing it in ChatGPT, but it's very difficult to do it on exam with ChatGPT. Okay, so if I multiply IC by the impedance of this guy, ZC, let's call it, what do I get? I get the voltage at this node, right? Or the voltage between these 2 points. Do you agree with that? Now, let's call this voltage V. Let's call this V1. So you know how to find V1 right now, so far. So do you agree with that? Vs times Let's call this ZR and let's call this ZL. Do you agree with this expression or no? I want you to understand what I've written. I just wrote a voltage division equation. I'm treating both of these as ZR in parallel with ZC and doing a voltage division. Now, the only difference with the usual voltage division is that in this equation, you don't know Vs, you know V1. So just one equation, one unknown, you can do it, right? So that is homework 3. And yeah. Just remember for this problem, you have to write it in exponential form. That's the only novelty of this. Okay, homework 4. Dumb way. Another dumb way. Nodal. Nodal is also dumb. Right now it's dumb. The good way. Superposition. It could work. What is obvious that can be done here without hurting anything? Combine the J3 ohm and negative J5 ohm. Just to make you confused, do you see that IB? That's nothing. That's just, there's no mention of IB anywhere in the problem. Do you see that? They are not asking for it. There's no dependent source. So they just put it there to stop you from combining them. Don't curse me. I didn't do it. Okay? So just combine them because that will get rid of one branch. So combine the inductor with the capacitor. Then still you have 2 nodes, so you can't do nodal. Do a source transformation, you get 1 loop. That's it. Okay? Just do transformation to the left side. You don't need to do it for the right part as well, because it will still give you 1 equation, 1 unknown. Yeah. What is that? IS is given to you. It's asking for the open circuit voltage. So what should you do? It's technically trying to do Thevenin. Okay? Remember, everything that was valid for time domain circuit is valid for phasor domain. So how can I find the open circuit voltage or Thevenin voltage? Sorry? You need to find the voltage between A and B. How do you do it? Sorry? No, there's no mention of Thevenin. It's just asking for the open circuit voltage. And remember, for open circuit voltage, you never touch the independent sources, right? That was only for equivalent impedance. So what do you do here?
Find an equivalent impedance.
And then multiply it, right? Find the equivalent impedance, resistor and inductors in series, and then parallel with the capacitors and multiply it by IS. It will give you the voltage across them, open circuit voltage. Downward current in a short circuit from A to B. So I can just connect a line from A to B with the downward direction. How do you find that current? Why? It shorted out everything in the circuit, so it will be IS, right? And the Thevenin impedance divide the voltage by the current. Okay, so exactly the same. Or you can, we already did that actually in the first part when we calculated the equivalent impedance. That's it. That's web work 20. I will record a video for your Friday lecture that is canceled, okay? No new concept. I will only help you understand homework, web work 21. I will also teach you how to do system of equation with complex numbers in MathCAD, because two of the problems in web work 21 cannot be done unless you do a system of equation. Okay? So you need to do them in web work. You might know how to do it, then nothing. But I will either record a video. If I can't do it, I will share you a link. I will share with you a link from Dr. Hartman lectures that has done like a couple of quarters ago, teaching a student how to use WebWork, okay? And then how to use MathCAD for this specific one. Yeah.
When is test 3?
When is it? It's some Monday from, it's,
Not next Monday?
no, it's not next
Not
one.
next week?
No. You will still have a lot.
Okay.
Yeah.
Because I couldn't find the syllabus